Okay, 6th grade. Our objective today is to talk about least common multiples. Very similar to how you find GCFs, but of course, a multiple is very different than a factor. So we're going to talk about that today. Before that, we're going to go over our warm-up and homework from yesterday's lesson. So starting with the warm-up, what did you guys get for the GCF for number 1? Briar. Good. Sean, number 2. Good. Number 3 said write 2 equivalent fractions that are equivalent to 30/40ths. Charles, give me 1. Good. 300/400ths. What's another one? Emma H. Good. 3/4. Anyone have other ones? Mary? Good. 6/8. Alyssa, do you have any other ones? Good. 60/80ths. Okay, one more. Justin? Good. 15/20ths. We could keep going. There's a lot we could say. So there's at least 5. Okay, number 4. Let's see how you guys did on these. Write the fraction in simplest form. Emma M. Good. 7c over 8d. Zach, what did you get for number 5? 17 what? Good, I just didn't hear you. 17/20ths. And then number 6, write them in simplest form. Are they equivalent? So, Donatus, number 6. What are they in simplest form? Good. 3/7. Are they equivalent? Okay. 3/7, and yes, they are equivalent. Any questions on the warm-up? Doug? Number 3? The answer's up there. Oh, I thought you said, can you see it? Go ahead. I'd rather not use decimals, but you can. So, I mean, it works, but I'd rather you not use decimals. Okay. Anyone else on the warm-up? All right, it's pretty easy. Okay, let's go over homework answers. Okay, practice 4.3. You guys had all of them? Okay, Adam, homework. Can you tell us what you got for number 1? 4.3.
I got yes.
It's really no. Okay. Briar, number 1. Oh, yeah, you don't have yours, sorry. Mary, number 1. Okay, what should it be? Good, it can be 1/3. Number 3, Charles. Or, sorry, number 2. Why did I say 3? My writing's just messy. Number 2. Charles. I said your name, I just... Good, yes. Number 3, Annalise. What should it be? Good, 5/17. Number 4, Sean. Yeah, I know. Thank you. I don't know. That's perfect. I wrote 3 options up here. That's perfect. No, Doug, number 5. Perfect. And I wrote 2 other options up here. So if you have any other options, these work as well. Matt, number 6. Good. Let me add 36. Oh, no, I have it up here. Perfect. I have both of those up there. Number 7, Justin. Perfect. Okay, I have those up there plus 2 others, so in case you guys have other fractions. There's a lot of answers you could have for these, so I can't possibly write every option you guys wrote. If you're not sure of something because you didn't use your calculator, let me know. Emma M, number 8. Yep, that works. Let me move this if it lets me. Hey. Okay, Adam, number 9.
I did 6 over 8 6.
1246 is the problem. You can't rewrite the problem.
44.92 seconds.
Okay, that works. Number 10, Mary. Good, 7/8. Number 11, Sean. Good, Zach, number 12. Good. Matt, number 13. Good. Donatus, number 14. Good. Number 15, Emma H. Good. 2/9. Number 16, Jeremy. Good. 1/8. 17, Charles. Part A first. Good. 2/5. Part B, Charles. Good. 18, Emma M. Good. 3x over 2y. Annalise, 19. Good job. Mary, number 20. Wow, you guys are doing awesome. Good job. So 4 over 5 st to the third, in case you didn't hear her. Emma H, 21. Good job. Sean, next one. 22. No, I mean, I'd say no, because you have variables in the numerator and on the denominator, and that gets very confusing if you change it to a mixed number. You still can, but I'd suggest not to. Okay, Mary. You simplified wrong. Yeah. Did you use your calculator, Mary, to double check? And did you type in 75 divided by 245? Enter, math, enter, enter. Okay. I would suggest using it just to check. I mean, I prefer you use mental math, but just to make sure that you simplified as much as you could have. Okay. Doug, 23. Good. 1 over 2h. I'll go back to it in a second, okay? Matt, 24. Good. Now this is kind of weird. They wanted you to use a number line. I'm not sure why. But all they wanted you to do was basically figure out the decimal so you know where to put them on the number line. If they're not at the same spot on the number line, they're not equivalent. Yeah, I agree, duh, like common sense, but that's what the book wanted you to do. I did not use the number lines. If you did not, I'm okay with it. Justin, 25. Good. 26, Zach. So is it yes or no? Okay, good. Yes? Donatus, 27. Okay, tell me what they are in... Okay, so tell me what they are in simplest form. Okay. Are they equivalent? Jeremy, 28. Good. 29, Annalise. Good job. All right, Doug needs me to go back. Okay. Questions. Matt. That's fine. That's not really simplest form, but I mean, I wouldn't mark it wrong. You just wrote it out in expanded form. I would not mark that wrong. That's very little. But try to remember to keep it together, like in exponential form, if you're just simplifying it. Okay? Emma M? Yep, I have one of those too. Yep, 21 over 48. Annalise? Okay. That works too. Yeah, that works. Justin. Yeah, it just goes in the same spot. Like I said, don't worry about them, but yeah. If this was 4/5, I would just put 2 dots there or put them on top of each other. Yeah, I will not give you a problem like that on the test. I don't like those. So, yes, you're good. Emma H. Me too. Yeah. Yeah. That's fine. I'm okay with common sense on these kind of problems. Matt. Oh, I thought you said 4 and 5. Say the first one that you had. That's fine. That's fine. Yeah. Yeah. Sorry. Anyone else on the homework? Okay, thumbs up, thumbs middle, thumbs down on the homework. Donatus. No, it's not a trick question. Okay, raise your hand if you got them all right on the homework. Great job. Raise your hand if you missed one. Okay, missed 2. What does that mean, Matt? Oh, you're fine. Those are, yeah, they're right. Adam? Okay. All right, it's not bad. All right, let's go to LCM. So open up your notes to page 11. Now, I will warn you, everyone, at least in this class, 6th graders always think that this is much harder than GCF, and then they tend to get confused when we mix them up. So let's first have a little discussion on who can remind us how to find GCF or what it is. Can answer either one of those. Sean, say something about GCF.
Well, there's 2 methods to do it.
Okay.
Write all the factors out, and sort of like pairs, and then multiply them, or you can do the factor tree.
Yep.
And circle the like factors.
Multiply them. Good. Annalise? No, you find the greatest one. When you list them all out, you find them. So whichever one is the greatest, that's the GCF. There's nothing to multiply. Emma M?
The GCF is
Good job. It's the greatest factor that can go into each of them. Emma, you want to add something or? Okay. Justin? Go ahead. Yeah. So it's the least multiple that they share. Kind of confusing to say it that way, but you're exactly right. And that's how I say it, but we're going to talk through 2 different ways to do this today. So remember, GCF, when you make your prime factorization tree, you circle the prime numbers that they have in common on both sides. Okay? Is everyone with me? Some of you guys look really spaced out today. You guys all right? With me? Okay. I know, but some of you are just like, okay, let's start with a couple definitions, okay? First one is multiple. A multiple is the product of the number and any non-zero whole number. So a multiple is the product of the number and any non-zero whole number. Correct. So, for example, who can list the multiples of 10? We'll just do a couple of them. What are the multiples of 10, Briar? Good. We could keep going. Okay, so what if I asked you, so that's the multiples of 10. We didn't list them all, of course. What if I asked you what are the factors of 10? This is important to know the difference. Charles, what would you tell me? You guys agree? Okay, remember, 1 times 10 is 10, 2 times 5 is 10. So the factors are the numbers that go into it. Multiples, like the definition says, is taking a number and multiplying, for example, 10 by a non-zero whole number. Okay? So maybe think of the factors are always the smaller numbers, the multiples are always the bigger numbers, if you ever get confused with those. You have to know what multiples are to do least common multiple. Okay, common multiple, this is common sense. A multiple that is shared by 2 or more numbers. A multiple that is shared by 2 or more numbers. Do you guys remember learning this last year? Okay, least common multiple. The least common multiple of 2 or more numbers, right? We wouldn't have guessed that would be the definition, right? The least common multiple of 2 or more numbers. Yeah, the book sometimes I'm not big on their definitions, but Adam. Okay. Least common denominator. I'm sure you won't guess what this one is. The least common multiple of the denominators of 2 or more fractions. Common sense, I know. Least common denominator, the least common multiple of the denominators of 2 or more fractions. Adam, you're already doing the Friday dance and it's not Friday yet. All right, Doug. No, yeah. End of class. What do I do, before or after? Okay, you guys ready? Okay, let's do, no, Jeremy? Okay. So let's do an example. Briar? Okay, but I'm thinking here. Let me show you this with 2 different methods. So like we did with GCF, don't write anything down yet. Let me show you the 2 methods. And then we'll decide who likes what better. So don't write this down yet, whether you know the answer or not. Okay, let's start with method 1. Method 1 is list the multiples of each number. So who can give us some multiples of 6 in order? Justin. Did you say 14? Oh, I thought you said 14. I'm like, we're in big trouble. Okay, but what did you forget? Okay, 36, 42. Give me one more. Okay, I'm just kidding with you. All right. Anyone want to give us some of the multiples? I was going to say factors. Multiples of 14. Sean. Give me one more. Okay. What's the least? Yes. What's the least common multiple, Annalise? Why? Yeah. It's the first multiple. It's the smallest multiple they have in common. Wow. Okay. There's method 1. Okay. Questions on method 1 before I show you method 2. Okay. Shh. Don't forget about hands, guys. Okay. Method 2. We're going to use the factor trees. Okay. So let's change 6 to 2 and 3. You don't have to write anything yet. Annalise, you can wait until you decide what method you like better, or do you already know? Okay, that's fine. All right, so method 2 is using the factor tree. All right, you need to find the prime numbers, okay, that you need to make sure you list every prime number that's represented on both sides. If there's repeats, you take the most. It's very hard to explain this. So here's what I mean. So there's a 2 here and there's a 2 here. Well, we know there's 2's on both sides, but we don't care about that. You just take 1, 2, because you have to have all prime numbers represented. If there's repeats, you take the side that has the most. You have to take a 3. you have to take a 7. You have to have every prime number represented when it's the least common multiple. 2 times 3 times 7 is 42. You get the exact same answer. You have to take every prime number. It has to be represented, and you have to multiply them together. I need to show you a harder example to explain the whole repeat thing, so don't ask me about that yet. Mary? Yeah, go ahead. Go ahead. Go ahead. Hmm? Okay.
And then you should circle the pairs and then circle the singles and then multiply them.
But you don't multiply the two 2's together.
Yeah.
Take one of them. Okay, yes, that's perfect. That's a nice way to organize it instead of making a tree.